quadrilaterals, right? So we have discussed about the quadrilaterals. So what are the things we have discussed in quadrilaterals? Types of quadrilateral. The definitions of the types of quadrilaterals we have discussed. What are the types of quadrilaterals? Yes. First is trapezium, then parallelogram, rectangle, rhombus, square, kite. Okay, these are the quadrilaterals we have discussed in last class. Okay, the definitions also we have discussed. Clear? Then today we will be discussing about the properties of quadrilaterals. What are the properties of quadrilaterals? Okay, based on that properties, if we are perfect in that properties then we can do the exercise questions. Right? Okay. Then, so in that properties, if we take, first we have to discuss the properties of parallelograms. Okay. See here, the first one. See, they have given as a theorems in that. Open the textbook. Page number 139. First one, theorem 8.1 if you see. What is that?
The diagonal of a parallelogram divides it into two congruent triangles.
Yes. The property is a diagonal of a parallelogram divides it into two congruent triangles. Okay. If we take, this is a parallelogram, right? So this is diagonal. Okay. So this diagonal is dividing this parallelogram into congruent triangles. Is it dividing here? Right? So these two opposite sides are equal, right? So these two opposite sides are also equal. This diagonal is a common. By using side congruent, we can write these two triangles are congruent. Okay? Clear? Then the next is yes, right. The first one is a diagonal of a parallelogram divides it into two congruent triangles. Okay. So the next one, what is the next point there? Theorem 8.2. In a parallelogram, opposite sides are equal. Okay. See, we take 8.2. In a parallelogram, this is a parallelogram, right? So opposite sides, this is equal to this one and this is equal to this one. Opposite sides are equal. Okay? Right. In a parallelogram, opposite sides are equal. Okay? If you take this one as a AB, CD, so AB is equal to CD. And AD is equal to BC. Clear? So in the third one, what is the theorem for 8.3?
If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram.
Yes. If each pair of opposite sides of a quadrilateral is equal. Okay? If you draw a quadrilateral here. Okay, so each pair of opposite sides, this is equal to this one, and this is equal to this one. If these two are equal, this pair are equal, so then we can say this one is a parallel. Okay, right. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Okay. Next one is, what is that theorem 8.4?
In a parallelogram, opposite angles are equal.
In a parallelogram, opposite angles are equal here. Okay. See, if we take this angle A, this angle C, this angle B is equal to angle D. In a parallelogram, opposite angles are equal. Angle A is equal to angle C and angle B is equal to angle D. Okay. So the next is 8.5. What is that?
If in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram.
Yes. If in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. Right? So in the first one they said it's in a parallelogram opposite angles are equal. In next property they said if in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. Clear? Next is 8.6. What is the theorem there?
The diagonals of a parallelogram bisect each other.
Yes, the diagonals of a parallelogram bisect each other. See here, if you take this one, this is the parallelogram. Here diagonals. Diagonal AC is bisect diagonal B. Diagonals of a parallelogram bisect each other. So in this parallelogram, see here, if this angle is x here, what about this angle? This angle is x here. So what about this angle?
X.
This is also x. Both angles are equal. The same way. Here, if it is how many degrees are there, so same that means angle here. If it is a y degrees, means this is also y degrees. Okay. Next is 8.7.
If the diagonals of a quadrilateral bisect each other, then it is a parallelogram.
Yes, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So one more property is there, 8.8, theorem 8.8. A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Okay. In this quadrilateral is a parallelogram if a pair of opposite sides. The sides are equal and parallel. Now we will go for the exercise questions. Exercise 8.1. See here, what is the first question?
The angles of quadrilateral are in the ratio 3:5:9:30. Find all the angles of the quadrilateral.
Yes, the angles of a quadrilateral are in the ratio 3:5:9:13. Okay, so find all the angles of the quadrilateral. Okay, I think this one already we have done, right? Okay, do once again. Here you have to write the first point is suppose the measures of four angles are suppose the measures of four angles are 3x, 5x, 9x and 13x. Okay? Clear? So, see, if we add all this, yes, angle sum property of a quadrilateral is equal to 360 degrees. Is equal to 360 degrees. Here you can write angle is some property of a parallelogram. Okay. Quadrilateral is 360 degrees. Okay. See, if we add, how much will be getting here? 3 plus 5 is 8. 8 plus 9 is
17.
17 plus 13.
17 plus 13, 30.
30x, right?
360.
30x is equal to 360. Both sides divide by 30. 30 cancel, 0 cancel, we will be getting another 3 ones, 3 12. So x is equal to 12 degrees. Substitute this x value in this one, you will be getting the angles. Here see, 3 into x means 3 12. How much?
36.
36 degrees. Then after that 5x. 5 into 12. That is 60. Then 9x. 9 into 12. 9 12 108, right? Very good. Then 13 into 12. Yes, 13 12.
156.
How much? 156. See here, if you add 36 and 60 plus 108 plus 156, you should get 360 degrees. Okay? If you are not getting 360 degrees, means somewhere we have done mistake. Again, we have to go back and we have to check. Okay? Yeah. What is the second question there? Is the diagonals of a parallelogram are equal. So we have to show that one as a rectangle. Okay, first we have to take a parallelogram. Here, see, in this 3 steps, whenever we are doing this quadrilateral process, we have to do the 3 steps. What is that? First is statement. We have to write. The given we have to write. Okay, what we have to prove. That one also we have to write. Then after that we have to do the proof. Okay, clear. Now, see this. Here, given. What they have given here, if we take, this is a parallelogram, right? Okay, so in this parallelogram, what they have given, if the diagonals of a parallelogram are equal, then show that it is a rectangle. Okay, so we have to write here given ABCD is a parallelogram in which AC is equal to BD. To prove ABCD is a rectangle. Clear? So how can you prove this one? We can take these two are the congruent triangles. We can prove these two sides are equal. Okay. Then one more thing, we can prove. We have to prove any angle. This angle A or angle B is equal to 90 degrees. Okay. If we prove the angles of the any angle, if we prove it's a 90 degrees, then that is a rectangle. Okay. First thing we have to prove these two sides are equal. Okay. Then after that we have to prove angles also 90 degrees. Clear? Right here. First we can take these two triangles. Okay, in these two triangles we can show it's a congruent. So try to prove in triangle ABC and triangle ABD Okay. See here, if we take triangles ABC and ABT. Okay. This is ABC. This is ABD. Okay. So what are the things are here common? AB is common for the two triangles, and BC is equal to BD. Mean this. Yes. Then and one more thing they have given. AC is equal to BD. Okay. See, this AC is equal to BD they have given. Okay. This AB is common. Right? These two sides are parallel. So using this side angle. Rule. Equal. Yeah. These two are equal. So by using this side, we can write these two triangles are common. Right. See here, AB is equal to AB. That is common. BC is equal to AD. Opposite sides of a parallelogram. Then AC is equal to BD, that is given. So therefore triangle ABC is congruent to triangle BAD by using SSS congruence rule. So therefore triangle ABC is equal to triangle BAD. This is equation 1 CPC. Since they have given ABCD is a parallelogram, right? In this parallelogram, sum of these two angles is equal to 180 degrees. Okay, angle DAB, again angle ABC. We take sum of these two are 180 degrees. In that already angle ABC is equal to BAD we have taken, right? If we prove that, we will be getting 90 degrees. ABCD is a parallelogram. Since ABCD is a parallelogram, thus triangle angle ABC plus angle BAD is equal to 180 degrees. Okay, BAD is 180 degrees. So this here we can write the result. Co-interior angle, sum of the co-interior angles is equal to 180 degrees or consecutive interior angles. So angle ABC plus angle ABC is equal to 180 degrees. Here you can write co-interior angles. From 1 and 2. Okay, instead of BAD I am taking ABC only from equation 1, right? In equation what we have got, ABC is equal to BAD.
So we can write X.
Yes, like that also you can write. Okay, so here see ABC plus ABC. So 2ABC is equal to 180 degrees. Divide by 2. So 2 will cancel. 180 by 2 is 90 degrees. So angle ABC is equal to 90 degrees. Then you can write that here. This shows that ABCD is a parallelogram one of whose angle is 90 degrees. One of whose angle is 90 degrees. Hence, ABCD is a rectangle. ABCD is a rectangle.